Hey guys, are you ready to start Chapter 12 of Fundamentals of Math? Alright, so we're going to go ahead and talk about Chapter 12, and we're going to start talking about your introduction to algebra. And Chapter 12 leads off with a lesson entitled Variables and Expressions. Alright, so we have to start off with a bunch of definitions. I hope you have your notes ready. Reminder that you're supposed to take notes for these lessons, and all of the work for your homework goes in your notes. So let's go ahead and define the word variable. A variable is a letter used to represent a number. Oftentimes it is a letter, but it doesn't always have to be a letter. Technically, it can be any symbol. But it's called a variable because variable, by definition, means change. When something varies, it changes. And when I have a variable like this letter x right here, all right, it means that x can be anything. Until I assign it a value, it can literally be any value that we want it to be. So because it changes, because it could change value, we're going to call it a variable. So anytime we see a letter in our equation, we're going to go ahead and identify that as a variable. So what is the variable in this one? We're going to go ahead and say the letter x. All right. Now, what are the variables in this one? Well, this one we have two letters. We have a and b. So our two variables are a and b. Easy enough? Cool. Now, in your book, if you read the instructions in your book, it talks about there's two different parts of an algebraic expression, variables and constants. But that's kind of wrong, and I feel bad about saying that to the book, but like, book, you're wrong. All right, because I teach pre-algebra and algebra 1, so I'm not trying to brag or anything. But I do know that in pre-algebra and algebra, they talk about coefficients as well. They talk about the three different parts: variables, coefficients, and constants. So let's go ahead and define the word coefficient. A coefficient is a numerical term in front of the variable. So in this one, if we wanted to identify the coefficients, all right, it's going to be the numbers. Numerical means numbers in front of a variable. So this guy right here is a coefficient, and this guy right here is a coefficient. The coefficients for this problem are 3 and -6. Now you might be saying, Mr. Lopez, isn't there a 6 in front of the end, not a -6? Well, I want to remind you that the sign is a part of the term. And if I have a negative sign here, I should have a negative sign there. Now you might be thinking, Mr. Lopez, isn't that a subtraction sign and not a negative sign? Well, yes and no. In a lot of ways in math, and if you ever want to talk about this more in depth, we can. But a negative sign and subtraction kind of mean the same thing. All right. So what are the coefficients of this problem? Well, any numbers in front of the variables, q is the variable, so the coefficient is going to be 15. Is -1 a coefficient? I'm going to say no, because it has to be in front of a variable. And notice that there is no number, there is no variable on this second term. So the only coefficient is going to be 15. All right, term 3 out of the 3 terms we need to learn to understand algebraic expressions, which we're going to talk a lot more about now, is the word constant. All right. So looking at this problem, a constant is a fixed number. So basically, whenever we see a number that is all by himself, that is alone, all right, or lonely, all right, a number by itself, you know, in that COVID-19 isolation quarantine, all by itself, we're going to call that a constant. So what are the constants for this one? Well, 3 is a coefficient and 2 is a coefficient. X is a variable, but the constant is going to be -1. All right, it's a number that doesn't have a variable. So does not have a variable next to it. All right, so what are the constants for this example? If I have c minus 5d, there are actually going to be no constants because c is a variable, all right, and d is a variable, and negative 5 is a coefficient. So this case right here, the constants would be none. All right, just because it asks to identify it doesn't mean there have to be one, and we want to get in the right mindset to identify all the different parts. Now this brings us up to another definition that you should for sure have in your notes: algebraic expression. An algebraic expression is a mathematical expression in symbols with at least one variable. So the key thing right there is it has to have at least one variable. If it has at least one variable, it is a algebraic expression. So because this has an x in it, the whole thing has an x, this whole expression is called algebraic. Now what's the opposite of algebraic? Well, a numerical expression. A numerical expression has no variables, and in this problem I have 15 minus negative 9. There are no variables here, therefore that makes it a numerical expression. Okay, so we're getting a lot of good definitions out of the way. One more little piece of good information for us to have, and this information is found on page 520 in your book, is that whenever you have two variables next to each other, or a number and a variable next to each other, anytime that you have two values next to each other with no signs in between them, notice there's no plus or minus sign, there's nothing, no terms between them, we consider this to be multiplication. All right, so whenever you have a number written next to a variable, or even a variable next to a variable, we consider that to be multiplication. So I could rewrite 5xy as 5 times x times y. And this is a really good important reason for us to get away from using the x as multiplication, because now that we have variables and we're learning more about algebra, x is a very common variable used. And it would look weird if we had 5x times x times y, because in algebra that means something completely different. All right, that means 5 times x 3 times y. That's a lot more complicated than what we want to get. So from now on, we want to try to use multiplication, use the dots for multiplication, or probably even better yet, all right, even better is to use parentheses. 5 times x times y. Why are parentheses better? Well, dots might look like decimals, and there are cases where you will have decimal numbers to evaluate. So maybe parentheses are the best way to go about it. Okay? Let's go ahead and look at example number 1 and try to identify the difference between variables, coefficients, and constants in the expression. Now note, the questions in the book are slightly different. They don't even ask about coefficients, but if we're going to learn this, we're going to learn this the correct way. So, just kind of keeping this in mind, on the homework, you guys will be answering questions like this, asking for all three. All right, on your book, it's a little different, but on your homework, we want to go ahead and make sure we got this. All right, what are the variables? Well, the variables are going to be any letters in the equation. So it looks like the variables should be x and y. Cool? Cool. What are the coefficients? The coefficients are the numbers in front of the variables. All right, so the coefficients would be 4 and negative 3. Okay, and what are the constants, if any? Well, the constant is going to be positive 6, so we're just going to go ahead and say 6. All right, so on your homework, you're going to have problems like that. Let's practice this a little bit more. All right, identify the variables, coefficients, and constants. So, for example 1 and skill check 1, we're going to do the same thing. What are the variables, if any? Are there any letters here? Yes. All right, the variable is going to be h. What are the coefficients? Are there any coefficients? I'm going to say yes. The coefficient is going to be 1. And where did I get this from? Well, Again, like I said, the coefficient is a number in front of the h. And it's kind of a tricky question because what is the coefficient in front? I'm going to say 1. Why is it not 0? Well, if there was a 0 here, this would be 0 times h, and 0 times h is 0, and h would not be here. But because h exists, it means that the coefficient is going to be 1. So, if you ever have a variable that has no apparent number in front of it, we can assume the coefficient to be the number 1. Now, what is the constant? The constant is going to be -3. -3 does not have a variable attached to it, therefore it is a constant. Okay? What are the variables in this problem? Well, I have two different letters. I have m and n. What are the coefficients? What are the numbers in front of the variables? Well, 7 and -1. So this would be 7, -1. And what are the constants? The numbers that are all by themselves. And so lonely, well, it's going to be 13 in this case. It's going to be 13. Cool? I think that's fine. All right. Now, let's go ahead and talk about how to evaluate an algebraic expression. In order to do that, you're going to replace a variable with a given number and perform the indicated operations. This is nothing different than any type of evaluation we learned. And my big helpful hint to you guys, if you want to pause this to write down this definition, you can. I'm going to go to the next slide. My big helpful hint to you guys is whenever you evaluate, you always put parentheses. And then you fill in the parentheses with the number they ask you to. In this problem, it says evaluate j plus 7, right? J plus 7, and they say that j is equal to 65. That means that wherever there was a j, we're just going to go ahead and put the number 65. And this is going to be the same thing as 65 plus 7. All we're going to do is add these two numbers together. I carry the 1, and I get 72. All right, so really evaluating is not that tricky. They're gonna tell you what the variable means, or what the value is, and you're gonna plug it in. Now this is important because remember, a variable can be any number it wants. All right, but in this case we're saying, you know what, variable j, you are 65. Deal with it, and then we solve it. So we deal with it. Skill check. All right, let's go. It says in this case we know that n is equal to 6. So wherever you see n, you're supposed to put a 6. So this is 7n, so this is going to be 7, 6. And in this case, because the letter is next to it, we have to multiply. All right, 7 times 6 is going to be 42, and that's our answer. All right, this one we were supposed to plug in 6 for n, so we have 30 divided by 6, which is the same thing as 5. And on this one, we have 13 minus 6, which is going to be the same thing as 7. Cool? Cool. The last little part of this lesson is just to remind you that you always use the order of operations. Whenever you are evaluating, you always use the order of operations. So let's look at this example. Evaluate 30 minus 3r if r is equal to 12. Well, if r is equal to 12, we're just going to go ahead and plug in 12 wherever we see r. And our order of operations says that we're supposed to multiply before we add or subtract. So this becomes 36. And now I have 30 minus 36. If you have $30 but you owe somebody $36, you pay them off, but then you still owe $6 extra, -6. The same thing can be applied right here, where if we were asked to evaluate here, and we do know that x is equal to -2, then 7 times -2 is the same thing. We have to do that first before we can subtract. It's going to be -14. And -14 minus 4 is going to be -18. Cool? Cool. If given multiple variables to plug in, we have to identify the right one. In this case, we do know that x is equal to 6, so we plug 6 in there. 6 times 6 is 36, and 36 plus 5 is 41. And we're just going to follow our order of operations. Exponents first and add. Cool? Cool.